In this hands-on coding session, we're going to explore the fundamental concepts of functional programming that we covered in the associated lecture earlier. We'll do this through hands-on Python coding examples, and our aim here is to understand these principles by writing and analyzing simple yet illustrative code snippets. Let's begin with the first concept of avoiding side effects through this example. In functional programming, as we discussed, it's crucial to create functions that don't alter any external state. And this means that our functions should avoid changing variables or states outside their scope. So, taking a look at this basic example of add numbers, it takes two integers as parameters and returns their sum. This function exemplifies avoiding side effects as it does not modify any external variables or states. And this is a fundamental aspect of making our functions predictable and more straightforward to debug. Now, moving on to a more real-world scenario, let's consider the extract log level function. This function takes a log entry and returns the log level, such as info or error or whatever else may be in the log entry text string that's been passed to this function. And notice how, again, it avoids altering any external state. Nothing is happening inside the function that is affecting anything outside the function. And it showcases the application of this principle of avoiding side effects by not modifying anything outside its own scope. Next, we move on to the concept of referential transparency that we covered earlier, where a function yields the same result for the same input, irrespective of when or where it is called. The function you see here called countGenomePattern exemplifies this. So given a genomic sequence in the form of the first argument and a pattern, the second argument, it counts how often this pattern appears in the sequence. This function will consistently return the same output for the same inputs of sequence and pattern, thereby being referentially transparent. Now let's discuss pure functions. These are functions whose output is determined solely by their input values and do not have observable side effects. This means that the function doesn't change any external state and is independent of the program's state changes as well. Let's consider this detect anomalies function that we have up on screen over here. It takes a list of stock prices and a threshold as the two inputs to the function and returns a list of anomalies. And here the list of anomalies are calculated trivially in this example. You have an average price being calculated that sums the prices and divides it by the length of the prices array, and then returns a comprehension where the absolute difference between the price and the average price being crossed by more than the threshold results in those prices being used to create a list that is output by the function. This function is a pure one. It doesn't modify any external variables, as you can see, or depend on any external state. That is, it's deterministic, relying only on its inputs to perform what it needs to do. Lastly, in functional programming, functions are treated as first-class citizens. This means they can be assigned to variables returned from other functions and used as arguments. As we discussed in the associated lecture, Python inherently supports this concept, though it's not explicitly shown in the examples we've gone through in this hands-on. Thank you for your attention, and let's continue to explore these concepts in the upcoming hands-on sessions as well as lectures. See you in a bit.